Hello, Assalamu alaikum. Today we will see lecture number 18 from the subject numerical methods. Today we will see the second method of finite differences. Only these two we have to do, forward differences and backward differences. The other differences are not in our syllabus, so we will leave that. So today we will see what do you mean by backward differences and how to construct the backward difference table. Okay. As you saw in the forward differences, the operator which we use was the delta. Okay, so for backward differences it is basically denoted by the operator but in the reverse form. So it is same with a little difference. If we are having function values as y1, y2, y3 up to yn, okay, then and y is equal to f of x for x1, x2, x3 up to x of n, then y2 minus y1, y3 minus y2, y4 minus y3, and similarly yn minus 1. All these are the backward differences of y. Now you will tell me it looks similar as we did in the forward differences. No doubt this is similar, but the representations are different. Like this is represented like operator y1, y2, y3. Not only this, but in the table, and similarly y of n. Okay, so these are called as the first order backward differences, right? Like we saw in the forward difference operator. Similarly, if you have to perform the differences of the first order differences, that will be the second order forward differences. Like similarly, the differences between the first order backward differences will be the second order forward differences. Like this. So we can have y1 will be equal to y2 minus y1. Second order forward difference will be equal to y3 minus y4, so on. The square yn minus 1 will be equal to delta yn minus yn minus 1, right? So the general formula for the first order backward differences at ith point will be delta yi will be equal to yi plus 1 minus yi. Similarly, if we will generalize this at the jth order, So at jth order of the forward differences at ith point is j yi will be j minus 1 yi plus 1 minus j minus 1 y of I. So this is what basically the backward difference is all about. It is similar with the difference in the operator and the difference in the construction of the table. Okay, so let us see how to construct the backward difference operator. Say xi, yi, delta yi, delta square yi, delta cube yi, and so on. Firstly, we will generalize this so that you will understand how to construct this table. 1, 2, 4, 5, 6. Or say we only have 4 points, it will be easier for us to do. Say this is x of 1, x of 2, x of 3, 4, y1, y2, y3, y4. So here delta y1 will be equal to y2 minus y1. Okay, but no, as I told you that there is a difference in construction of the table, so we don't write it like this. We construct the table in the lower half. Okay, so whenever we perform the difference between these two, it will be represented in the second point, not in the first point. Like in the forward difference operator, we constructed it in the first half of the table, but in this backward difference, we construct it in the second table. So this will be basically delta y2 will be equal to y2, not y1, will be equal to y2 minus y1. Similarly, delta y3 will be equal to y3 minus y2. Delta y4 is equal to y4 minus y3. We have to construct it in the lower half. The second order will be over here. Second order of y3 will be equal to delta y3 minus ulta wala y2. Then second order y4 will be first order y4 minus first order y3, and then the last one will be represented over here. Delta y3 y4 will be equal to delta square y4 minus delta square y of 3. So this is how we represent the backward difference order, and this is how we construct the backward difference table. Now in the next lecture we will see 1 or 2 examples, and we will make sure that all these points would get cleared more. Thank you.